Hi, I thought I would graph a video on graphing from the vertex form and then changing the vertex form into the standard form. So the first thing I'm going to do is I'm going to graph this equation, and this vertex form I can find out very quickly what my vertex is. And my vertex is the opposite of that, so it's going to be -2. And then my y value, or my k value, is +3. So I'm going to go -2 and then up 3. So that kind of gives me that value. Now I can find my y-intercept here by just plugging in 0 for x. And so y is equal to 2 squared plus 3, so y is equal to 7. So that's going to be 1, 2, 3, 4, 5, 6, 7. And I know that that's going to be, I think that's going to be right. And the reason I think that's right is because I have, it's going to be up, facing up, because a is greater than 0. And my a value here is 1. So from this graph, I can do my axis of symmetry, which is just my x value of my vertex. And I can count over 2, and then 2 to the right, so it's going to be 2 to the left. And then I can draw my parabola that's going to look something like this. And of course, yours doesn't have to be perfect, because mine is never perfect. So if I look at this equation, or this graph, I can describe this graph the same as what we did for our graph using standard form. So looking at this graph, I already have my vertex, and my vertex is -2, +3. My axis of symmetry, we already talked about, and that was of symmetry. And that is just going to be x is equal to -2. So then from there, I can talk about my zeros and my end behavior. Well, my zeros, I don't have any real zeros. So I know I'm going to have some imaginary roots. And so I know I'm going to have to use the quadratic formula. And I can't use the quadratic formula yet because it's not in standard form. So I'll wait till I put it in standard form to use the quadratic formula to find my imaginary roots. So the next thing that we talk about here is my domain and my range. So my domain is what values of x do I have a graph for, and I have a graph for all real numbers. And then my range. What values of y do I have a graph for? And I have a graph for all y that is greater than or equal to 3, because that is my y value of my vertex. I can also write this as 3 to infinity. Okay? Either way is right. You do not have to do both. The next thing I can talk about is my intervals of increasing and when my graph decreases. So if I'm reading my graph from left to right, I can see it is decreasing as I'm going from -infinity all the way to when x is equal to -2. So x is equal to -infinity, it decreases all the way till I hit the vertex point. And then, so that would be decreasing. And then my increasing interval is all the way from the point of -2 to +infinity, because as x gets bigger, it keeps going up and up and up and up and up. So that is going to be from -2 to +infinity. Then let's talk about our end behavior. Now our end behavior is, I can see both ends are going to +infinity. So you write it like this. As x approaches -infinity, f of x approaches +infinity, because as x goes this way, y goes up. And as x approaches +infinity, f of x goes to +infinity also. So if you notice the pattern with parabolas, that it's either approaching +infinity and +infinity, or -infinity to -infinity. So that's kind of graphing it and then using our characteristics to describe the graph. So from that point, we can talk about some transformations. And you can see that my vertex, I've moved to the left 2, and I've moved up 3. And that's indicative of what's going on here inside the parentheses. So it's the opposite of what it is. So that's going to the left 2, and up 3 is my vertex. So we could describe that by that. Now, going back over here and thinking, okay, how can I turn y is equal to x plus 2 squared plus 3 into the standard form of a quadratic equation? And all I'm doing here is basically just simplifying it. So I'm going to actually square x plus 2. So I have to do x plus 2 times x plus 2. I'm going to FOIL it out. So that's going to be x squared plus 2x plus 2x plus 4 plus 3. And then at that point, I'm just simplifying it. X squared, plus 4x, because I'm combining these like terms, and then I'm combining 4 and 3, and that would be 7. So this would be my quadratic in standard form. Now, and that matches up exactly with the fact that we said the y-intercept over here was 1, 2, 3, 5, 6, 7, 0, 7, 0, 7. And if you look at my c value in standard form, it's 0, 7. So we talked a little bit about finding the zeros, and we know that the zeros are going to be imaginary. There's no real roots. So I know I'm going to have to use the quadratic formula. So x is going to equal the opposite of b, plus or minus b squared, which is 16, minus 4 times 1 times c, over 2 times 1. So at this point, it's x is equal to negative 4 plus or minus, and then that's going to be 16 minus 28, which is negative 12, over 2. So if I simplify it even further, plus or minus 2i times radical 3 over 2, and then I can divide each of my terms by 2. So that's going to be x is equal to negative 2 plus or minus I radical 3. And this would be my two imaginary roots. So hopefully that'll help you with some of what we're doing in class. Maybe on a, you can pause me, go back, look at it, but you can do this for all of your standard form equations and all of your vertex form equations.